Thank you very much. Martin and I are here to talk this morning about why Agile software development works, not just how, because you can go out in the world and find a lot of books about Agile software development, but all of these books are about how Agile software development works, but they don't really focus much on why it works. And those of us who have been following Agile software development for a while are very interested in why these things work, because some things in Agile software development are very, very non-intuitive. They don't seem to make sense until you've tried them. And for some of the really key practices in Agile software development, we have essentially shown that they work and then reverse engineered why they work. And a lot of what Martin and I are going to talk about this morning is why these parts of Agile software development work so very, very well. We both work for ThoughtWorks, and we're a well-known Agile software development company, and we've proven to ourselves for more than a decade that these things work really well. And so what Martin and I are going to talk about this morning really is the essence of agility, and this is the first part, the essence of agility, and I'll pass it over to Martin.
So when at ThoughtWorks we started working with Agile software development, really what we saw was just little bits of information, and we saw it was really hard to get people to take Agile software development seriously. Now, over the last 10 years, we have seen that steadily change. And now, in many parts of the world, Agile is seen as, if not the mainstream, as certainly a mainstream alternative. And we see major conferences, we see certifications, we see a lot of these trappings of a more mature approach to developing software. But in the course of all of this development, one of the things that has also happened is that we begin to see that a lot of the things that people say about Agile software development no longer ring true with what many of the original developers of Agile software felt. And this is in fact a very common phenomenon that affects all sorts of different things, and it's something that I refer to as semantic diffusion. The original ideas, as they get passed from person to person to person, the ideas get more and more diffuse, more and more fuzzy. And as a result, we often find ourselves now going into an organization that has been doing Agile perhaps for several years, and we go in and we look at what they're doing, and it's nothing that we would recognize as an Agile approach. And this is a problem because it means that people are not really understanding the opportunities that this technique has for them. And therefore, they're not able to truly judge whether it's applicable to their situation. Now, semantic diffusion, as I say, it's a common problem with many things, and really one of the key things you have to do to deal with it is to just constantly remind yourself what is the core essential ideas that you can concentrate on. Now, in my case, understanding that comes back to an essay I wrote back 10 years ago, right at the beginning, before we even came up with the word Agile, called The New Methodology. And if you're interested, you can go to that URL or just Google for New Methodology and you will find it. And in that essay, I really highlighted what I saw as two key distinguishing features that made the differences between the Agile world and the more traditional plan-driven world that was the main context at the time. Now, the first of these was the attitude towards planning. In the traditional notion of plan-driven software development, planning is seen as an activity you carry out before you do the actual work that you're going to do. There's an English phrase that I have up here: plan your work, work your plan. You plan first and then do your thing. Essentially, this is a predictive approach towards planning. And it is predictive because the idea is that the plan is a prediction of how the work should go. And this also very much affects your success criteria. Because to be successful, the measure of success in a plan-driven world is to say that you have actually carried out your work according to your plan. And so when often you hear people saying, we had a successful project because it was on time and on budget, that's a predictive mindset. We succeeded because it followed the plan. Now, this kind of predictive approach is useful in many, many situations, but one of the things that it does have in terms of software development is that it depends on the fact that you're able to get a clear and stable set of requirements. Because if you can't get clear requirement stability, then everything else that follows from the plan is not going to be stable either. And so not just does your plan depend upon your requirements being stable, but your entire software development process depends on your plans, on your requirements being stable. And herein lies a difficulty. Because whenever I go to software projects, I ask this question, are your requirements stable? In fact, I'll ask you this question now. How many of you are working on software where you've got requirements that are unstable, that things are changing? How many find themselves in that situation? As usual, it is most of the audience. How many have stable requirements, everything's solid and not shifting? There is usually one.
But there are a few people who didn't raise their hands at all, so I'm not sure what they're doing.
So the plan-driven community knows this, and so they say, well, we need to stabilize our requirements. And they come up with all sorts of techniques that can be used to do that, in order to do that kind of stability. But we find that this is actually really kind of hard. And this is the first shift in the Agile world. So the Agile world says, well, if we need this situation where our entire software development process is dependent upon having stable requirements, and we can't get stable requirements, well, maybe what we should do is get rid of a dependency. Break that dependency and come up with a software development process that is tolerant towards changes in requirements and changes about how things go. And that is one of the core distinctions. But it goes a little bit further in this phrase that I really like from Mary Poppendick. What she's saying here, of course, is that not just should we be tolerant of changes of requirements, we should actually see them as an advantage. And the fact that we can change is a big plus for us. And this is very, very central. Now the question then is, how do we do this? Well, it means the basic idea of planning, that we do some plan and then we execute that plan. In the Agile world, we switch over to what we call an adaptive planning approach, which is that we go through this cycle of plan and execute many, many times on a project. So you will see every week, every couple of weeks, we replan, readjust based on where we are. And furthermore, we look to release the software at frequent intervals. One of the primary things that we find we are doing at ThoughtWorks as we come into an organization is not just do we have to get the development side working, but we also have to get the whole organization's deployment and delivery into a cycle so that we can put software into delivery every couple of weeks or so. That change causes a great and profound shift. So the first shift from between Agile and the traditional world is this switch from predictive planning to adaptive planning. Now, one thing I should point out, in order to make adaptive planning work, you have to change your approach and your thinking towards software design, and to come up instead with an evolutionary approach to software design. But the design is something that is also constantly changing and evolving as you go. Now, I don't have time to really talk about how you do that. There's a whole bunch of techniques that are out there that enable this kind of stuff to happen. And there's another paper I can point you to called Is Design Dead? Another thing I wrote 10 years ago that really talks about this change in the nature of design. These technical practices are a very important part of Agile. One of the common problems we run into when we see companies struggling with Agile is that they take the project management stuff but don't take the technical stuff. And they get into a great deal of difficulties by doing this because they don't have software that's designed for change. And this is particularly a problem with people who say they're following the Scrum approach. Although it's not inherent in Scrum, it commonly goes with that. So if you are doing an Agile approach or considering an Agile approach, make sure you pay attention to these kind of technical things as well. So that's our first distinction, adaptive versus predictive planning. So for the second distinction, I want to show this rather old photograph. Does anybody recognize who this is? No, not Ford, but you're philosophically very close to him. Taylor, yes. Frederick Winslow Taylor. One of the most influential people who has affected life in the 20th century, perhaps more than anyone else. And his great phrase was this one here. Really saying that in the past, people who were doing the work would decide how to do the work. And his view was that should change. That instead, a separate group of people should decide what process people should follow, and then people should conform to that process. It's an approach often referred to as scientific management. It has strongly influenced the whole way we think about work and how we do work in the 20th century. In the terms of a software process, you can think of it as saying we have process designers who come up with a software process that people should follow. And then when we actually want to apply this to a project, we go out and we find some people who fit into the rough categories of the process, and then we slot them in to the various places within the process. And that is the traditional approach towards thinking about process. Now here for the shift, I have a slightly longer quote for you to read. Now the point of what Alistair is saying here is that we tend, because we're computer people, to be used to manipulating these highly precise things called computers and plugging them together. In fact, I saw people give talks where they said, software process is software too. We can treat the way we build software like a computer program. But the problem is, the key things that do things, the key actors in software process are people, and they are not predictable. They do not act in this very circumscribed linear way. And so his view was, and this is very much the key agile notion, is that instead we need to think differently when we have people as primary actors in the process. And in fact, rather than coming up with a process and fitting the people into it, we reverse things. We get a good group of people who can work effectively together, and then they choose the process that they follow. And so that is the second shift. Shift from saying the process comes first and the people fit in, to saying the people come first and they decide what process is the most effective for them to follow. Because even if you get good people, it's been observed that you will often find that a process can often stifle people and stop them working very effectively. So it's very important that the software development team choose their own process. And that, to me, is the essential difference between agile and plan-driven approaches. The attitude towards planning and the attitude towards people.
Okay, the next aspect of why this works is communication. So let's talk a bit about communication as it applies to software development. In our world, communication trumps technology, meaning that we view communication as a more important aspect of software development than we do technology. Now, I'm sure no one in this room has ever been on a failed software project, but if you would, for just a moment, imagine what a failed software project might be like. So fantasize for a moment about what that might be, and think about, did it fail because of a technology reason, or did it fail because of a people issue? The famous book, Peopleware, by DeMarco and Lister, has a quote that says, it's always a people problem. In software, people always end up being the most important thing, and communication between people becomes a really, really important thing. And part of the reason for this is that we are highly social creatures. Notice that the worst punishment in prison is solitary confinement. The worst punishment in prison is being taken away from the other murderers and rapists and thieves and put by yourself. That's how social we are. We would rather hang out with really undesirable people than be alone. And this is reflected in some of the literature in the Agile software world. Alistair Coburn has this great graph where he's done analysis of the effectiveness of communication channels. And he models it similarly to the way that you would model heat transfer from a heater or air conditioning duct. The further away you are, the less effect that you get. And what he says in this chart is that the most effective way that you can communicate technical information is two people at a whiteboard. Because you can see each other, you can see body language, you can hear tone of voice, you can see facial expressions, you can ask questions and get responses, you can draw pictures. Really, really super effective way of communicating, a very rich communication channel. But if you go to the opposite end of the spectrum, you see two people on email or two people on paper, which doesn't even allow Q&A. This is exactly why trying to come up with a really elaborate set of requirements and shipping them 6 or 7 time zones away to another country and expecting them to produce software with no further input is doomed to failure. Software is a very highly nuanced thing, and trying to communicate all that nuance in a very flat piece of paper or an email is never going to work particularly well, which is part of the reason why a lot of the early outsourcing efforts were not particularly successful, because you cannot specify enough on paper to allow them to be able to create something, and you break that feedback communication loop with those developers who are now isolated many, many time zones away. Now, it's very common in the United States for some of the states now have a law that you're not allowed to speak on a cell phone while you're driving. Is that true here? Oh, yes. It is, okay. Have you ever wondered why? Now, certainly there's a little bit of fiddling with buttons, but I'm sure most of you here have broken the law at some point and talked on a cell phone while driving. Have you ever noticed how distracting it is? Just the talking on a cell phone is much more distracting. And yet, I don't know of any state or country that makes it illegal to talk to the person in the seat next to you when you're driving. And part of the reason that it's so distracting talking on a cell phone is because huge parts of your brain are trying to reconstruct the missing communication channels that exist when you have a face-to-face communication. You don't even realize that those parts of your brain are engaged, but they're engaged and they're working very hard because the only communication channel you have is this staticky voice over your cell phone, and you're trying to recreate all the other parts of this communication channel. And of course, the early founders of the Agile software movement, including Martin, realized the value of communication, because if you look at the Agile Manifesto, there are 2 items on here that specifically call this out as an important feature: individuals and interactions over processes and tools, which is not to say that we don't like the things on the right, but we like the things on the left better, and customer collaboration over contract negotiation. Notice this is very much a face-to-face communication rather than try to specify everything out in infinite detail on a piece of paper somewhere. And there's an interesting story that I can tell based on some project work that ThoughtWorks has been associated with. And this happens in the African country of Malawi. Now, Malawi is a very, very poor country. In fact, they have a very little electricity, they have very little infrastructure, and they have these medical clinics that they have set up, these practitioner clinics, and they have nurses who work there who have gone through a short training period. And the villagers walk for many, many meters, kilometers, to get to these sites. Some will start before daylight and walk for several hours to get to these clinics essentially in the middle of nowhere, and for health issues. And one of the big problems in Malawi is malnutrition. And so these nurse practitioners, one of the things that they do is try to gauge whether the children in this particular rural area are malnourished or not. And they've done this for many, many years. But part of the problem was that they're collecting all this information, this data, and on paper, and then shipping it to a central office. But of course, Malawi doesn't have particularly good infrastructure, so it takes a long time for that information to reach the government, where it kind of stacks up in piles of paper, waiting for someone to come along and react to it. And the problem, of course, is it takes so long to react to it that there will be really serious outbreaks of disease and malnourishment that go unnoticed for weeks at a time because they don't have timely information about how this works. UNICEF looked at this problem, and they asked themselves this really difficult question: how do you automate something in a country that has very little electricity? But they noticed something interesting. The people in Malawi are very, very social. In fact, the penetration of cell phones is more than the penetration of electricity. Nokia makes a special model of cell phone that keeps a charge for 3 weeks at a time or more. The people in Malawi literally walk to the village to charge their phone because they don't have electricity. And they buy prepaid phone cards so they can keep in contact with their family. And UNICEF noticed this and realized that this was a useful IT infrastructure, cell phones, and in particular, SMS on cell phones. And so they set up a project called Rapid SMS that allows the nurse practitioners to construct a very specifically formatted SMS message that has information about the child that's standing in front of this person right now. Now, by using this infrastructure, they can get almost immediate reports from a region and be able to collate that information and react to it quickly enough so that it makes a difference. And that time makes all the difference. And this project is an open source project called Rapid SMS. And you can contribute to this if you like. It's a purely open source project. It's written in Python using the Python web framework called Django. In fact, ThoughtWorks at our last North American Away Day made some contributions to the Rapid SMS project as an open source project because we support the kinds of things that they're doing there. Finding the correct communication channel was the key to solving this problem. And it turns out that shows up a lot in Agile software development as well. Finding the correct feedback loop, finding the correct communication channel sometimes makes all the difference. Which brings me naturally to the next topic, which is about feedback. And Martin is now going to insult your French cuisine.
Well, no, I don't think I'm going to insult it. I'm just going to say, to help illustrate the role of feedback in software development, I'm going to mention something that I consider to be a very high point of world gastronomy, which is my fruitcake that I make.
See, I told you he was going to insult you.
Now, French do great food. I mean, I consider France to be the second greatest food country in the world. Oops. But now, fruitcake is part of this story. The other part of this story is taking a shower. And typically in a hotel room that you've never been in before. So what's the difference between taking a shower in an unknown hotel room and baking a fruitcake? Well, this has to do with two ways of thinking about process. And this is a distinction that was made by Ken Schwaber right back in the early days of the Agile world. He essentially said that there are two forms of process out there, the defined and empirical process. And the fruitcake and the shower are examples of these two. So let's begin by saying, well, in a very simplified view of any process is to say, well, we have certain inputs and controls, we have a process that we do, and a certain outcome that we expect from the process. When we're working in the world of a defined process, such as a fruitcake, what we do is we understand the process really well. I know how to bake the fruitcake. I've done it many, many times. So I get the right amount of ingredients, I combine them the same way each time, I put them in the oven for how long I know it is to be, and out of the time, every time, comes that same fruitcake that is capable of keeping me going for months. That is the defined process. It's well understood. I can set everything up in advance, let it run, I get the output. When I take a shower in an unknown hotel room, I use the other kind of process, the empirical process. And that's because I don't really know where that dial is in terms of the heat of the shower. And so what I do is I will run the shower for a bit, stick my hand in. Is that too warm? Is it too hot? Adjust the shower appropriately. I get in, Maybe, you know, it's okay at the beginning, but as I warm up, I want the shower a bit hotter, so again, I will adjust the shower. So what I'm doing here is I'm looking at the output, inspecting that output, and then adjusting the inputs based on what the outputs are. And that's because of the fact I'm dealing with something that's much less known. Okay, it's still a relatively simple process. I really have only one dial to touch. But I don't know in advance exactly where that dial will be. And that is the difference between these two things. Now, the key thing that Ken Schwaber brought out from this, he understood these ideas through interactions with process engineers from the chemical industry. Originally, Ken had been a developer of software to support traditional approaches. He had clients like Coopers & Lybrand, who he would sell software for to support their software development process. And he wanted to understand better how software development processes worked. And so he went to DuPont to talk to their process engineer people to get a sense of what was going on. And that's where he picked up this idea, this notion of empirical and defined processes. And the key point is you have to use the right kind of process for the definition for the right kind of process. So if you have a chemical plant and you know all the inputs and you know how everything operates well, then you can use and should use the defined process. But on the other hand, if there are unknowns and uncertainties involved, then using a defined process is actually quite dangerous. Instead, you have to choose an empirical process. And this, of course, is how it notions to software. In software, as I mentioned earlier on, we have all of these unpredictable, non-linear components called people running around. So you can't use a defined process effectively in those circumstances. Instead, you need to use an empirical process. And that means you need to have some way of inspecting the output and putting it through in a feedback loop to affect how you're doing things. And that's why feedback is such a central part of so much agile thinking. Whenever people and our colleagues go out to clients, we're always looking for ways in which to introduce feedback loops into our software development approach. So I want to talk a little bit about some of those feedback loops that we introduce. There's a lot more than I've got time to mention, but I'm going to mention a few of them. So to illustrate one of them, I'm going to show you our office building in Beijing. We only have one floor of this office, and the interesting thing is that you can tell from the street which floor it is that is the ThoughtWorks floor. And you can see this perhaps a little bit if I kind of zoom in a little bit. And you notice that one of these floors, the windows are covered with little blobs and things. And that's post-it notes stuck onto the walls. Go into the office and what you see is post-it notes covering over the windows. And that is a demonstration of how we like to feed back the project plan of how we work. Go into any ThoughtWorks project almost anywhere around the world and you will see card walls on this wall which show where we are in a certain part of the project. Various tasks that we need to carry out, captured as user stories, will be stuck up on the wall, and that position on the wall indicates how far we are. Have we decided to start work on them yet? Are we working on them? What stage in our little workflow that they go through? And you can walk in and pretty much by going up to the card wall, you can get a real sense of what the team is actually working on. But where this is particularly interesting is that this is not something that's only visible and only relevant to the managers of the project. Instead, it's visible for everybody. And this is one of the core elements of the planning approach that we encourage, is that planning isn't just something that's visible and understandable to the project manager, it's something that's visible and understandable to everybody. That everyone can see where we are. When I used to go into traditional software projects and look at the project plan, it was something very complicated and something that most developers on the team didn't care to want to understand. And they knew it was all fiction anyway. But with an Agile project, you want everybody to be participating in that plan. So it's very important that everybody can see what's going on and everyone understands what's going on. And this is even the case if you use electronic tools. Here's another team room, this one in Atlanta, and a project that we've been doing there for several years. And here we may not have so much the physical card walls, but we have electronic ones. And what you see are the projectors here projecting on to the screen. And what they're showing is the card wall from our project collaboration tool called Mingle. And that gives us a virtual card wall. This is something that's also very important in offshore projects where we're collaborating between India and Europe. We need to be able to see the card wall everywhere that matters. And so we have an electronic card wall that mimics the physical one that we use when we're all together as a team. Most teams will prefer a physical card wall because it feels closer and you know you can shift the cards yourself. But an electronic one is often necessary if you have this degree of distance. Now, another important part of a feedback loop that we see is knowing where we are in terms of the build system. One of the key elements of Agile software development is we have this notion that there's only one way of measuring progress, and that is by working software. As we build pieces of working software and we get them into a production-ready state, we can see our progress. No other indicator is as important as this. And that is, again, because of this notion that we have to be sure about where we are in the software development approach. So as a result, we find that the build process becomes very important. We always have to know, does our software integrate? Does it build well? What stages does it go through in the various gates of acceptance testing to the point at which it is production ready? Some projects early on like to use green and red lava lamps to show whether the build was okay or not. And we often come up with quite elaborate techniques for showing where we are in the state of a project's build. This one here, we're using something that is a more computerized display. But again, this notion of where are we in the process? And so that when the build breaks, everybody can tell, and everybody can do something about it. This gives us a feedback loop as to the basic health of the software.
And it's worth mentioning, this particular view is a tool called CC Board, which is an open source tool. What you're seeing here are the status of multiple builds on that project. And green, of course, means that the last build was successful. The darker green that you see pulses because it means that I'm now building and the last build was successful. Pink means that the last build failed, and red pulsing means that I'm currently building it and the last build failed. This is a pretty common thing that we do a lot in the software development world to try to support Agile software development. We created this as part of project work, but then we open sourced it so that other people can take advantage of it. And ThoughtWorks as a company has a very long history of open sourcing these infrastructural elements to help support Agile software development, like continuous integration, cruise control, testing tools like InUnit and Selenium. This is, as I said, a tool called CC Board, which is basically a front end on a continuous integration server so that you get one nice comprehensive view of a large number of concurrent builds that may be going on to support different things in the project.
And this notion of using testing as a feedback loop is a very central part of things. That we constantly question whether we're actually building software that works effectively by layer upon layer of testing. In early stages, we want a very fast testing loop, so we use fine-grained unit tests to test things very quickly. And then as we go further down the pipeline, we use longer and more forceful tests, end-to-end acceptance tests, performance tests, and the like, to get more and more sure of the software quality of what we have. And we do this right from the beginning of the project, so we have a constant feedback loop as to the quality of the software and whether it's appropriate enough. And that, again, is the use of feedback. Now, these feedback loops are things that are very broad in terms of a whole project team. The next feedback loop I want to look into is something much more close involving the way in which people collaborate and work together. In particular, around the notion of one of the more controversial aspects of extreme programming, which is that of pair programming. And I just want to point out now a little marker for the future that it will be important for us to explain exactly what a plastic kangaroo is doing on the project team, and Neal will explain that later.
Critically important. I'll get to that in a bit.
So, pair programming. Here we have a couple of software developers, actually from a while ago at ThoughtWorks, who are working on a piece of software together. And this is a thing that we now have used widely at ThoughtWorks. Pair programming was very controversial early on, and now we use it very heavily. And there are many reasons why it's effective, but to illustrate one of them, I would like to show you two of my favorite places in the world. This is the first, not too far from here. Hopefully many of you have visited it. It's in the Loire Valley. I visited a couple of years ago. One of the most interesting and beautiful gardens in the world, designed very much to follow the French style of Renaissance gardens, very formal and at the same time very beautiful. The thing that I particularly like about this shot is that it is the vegetable garden. It's a working vegetable garden, and the vegetables are used in the restaurant at the chateau, and yet at the same time they are arranged in a way that's very aesthetically pleasing. Another garden I like very, very much, and quite a different garden, is this one in Heligan in Cornwall, in England. It's a garden that was built originally in the 19th century, and then it became lost because the family that owned the estate died out. The estate got into a legally strange state, and as a result, the garden got all overgrown, and it was effectively lost. And then about 20 or 30 years ago, some enthusiasts managed to raise money to buy the estate, and they cleared away a lot of the stuff that had grown up over time and restored the gardens to what they were like in the 19th century. And this particular section of the garden is referred to as the jungle. Cornwall has these areas where you get quite a cleft in the valley, and that gives you a microclimate that allows you to grow plants that you can't grow otherwise in England. So this area of the garden has a lot of tropical plants that you just wouldn't be able to grow anywhere else. Now, these are two very different gardens. One is very ordered, straight lines, geometrical shapes. The other looks like as if it's supposed to be completely natural. I mean, it's very unnatural. Those plants are not native at all to England. But when you're walking through the jungle, you have this feeling that you could be just in nature. And what we see is that these two gardens are appealing to different parts of the brain. You may have heard that in the time that the brain is kind of divided into these two processing halves. The left side of the brain, which is the more logical side, which is all about logic and order and things being arranged into nice patterns, and the right side of the brain, which is more holistic, creative. I think of it as the romantic side because I think of it in terms of romantic poetry or romantic music. This kind of way of thinking about the brain, of course, is very common. One book that I very much recommend if you're interested in thinking about how the brain works in terms of software development is this one here by Andy Hunt. But in going back to our notion of the brain and how it divides into the logical romantic parts, how does this play into pair programming? Well, it plays into it because of the fact that when you see two people programming at a computer like this, what's happening is that different parts of the brain are taking priority in the two participants. Typically, the person who's typing on the keyboard, they're in the Villandre part of the brain, the logical part. They're thinking about how do I make this particular piece of software work? How does it fit together? And they're thinking in very concrete, logical steps. But the person who is participating with them, often referred to as the navigator, as opposed to the person on the keyboard being the driver, that navigator, their brain is in a much more Heligan mode. They're thinking in terms often of broader pictures. And they're often able to ask the why that goes with the person on the keyboard's how. And this, of course, is a very important part of development. Often in terms of software development, when you're focused on trying to get something work, you often can miss the fact of whether you're even taking the right path to get there. And it needs somebody who's just a little bit detached, who isn't concentrating on exactly how to fit the pieces together, who is able to say, hang on, this is the whole wrong approach that we're taking here. We need to take a different and easier path.
What this means then is that because you can only use one half of your brain at a time, it's almost like you have two processors but only one bus. So the only way to apply one full brain to software development is to use two half brains at one time.
So as a result, with pair programming, it's not so much you've got two people working at the same time on the same piece of work, it's you actually got one full brain operating. And so the last part of the feedback loop that I want to mention for Agile software development comes back to this lovely quote from Kent Beck. Perfection is not something we do, but not something we achieve, but something we're constantly doing. We're constantly trying to perfect what we do. And so we see these feedback loops in terms of software development with pair programming, which is a continuous review process, in the planning approach, because we're constantly seeing our plan and seeing how it works, in the testing approach, which is constantly checking if our software is healthy, but it also applies to our entire process of software development. So a common thing you see on Agile teams is that every so often, usually every week or two, we do retrospectives where we look at our whole software process and we say, how well is it working? What are the things that we are doing well? What are the things that we're struggling with? What are the things that are puzzling us? And how do we change our software process in order to take advantage of these things? And this is even, I think, brings more this notion of the team owning the software process. Not just does the team decide how we're going to carry out our software development process, the team decides regularly how to change it. And that as a result, we see a constant tweaking and changing of the software process. There's a phrase I often like to use that's saying, if a team is doing extreme programming,